Hello and happy Friday. I want to try something a little bit different today for your notes over story problems with inequalities because I think sometimes you guys focus a little bit better when you can just put on some earbuds or some headphones and listen to the notes without any other distractions in the class. So if I'm going too fast at any time, feel free to pause the video. We're going to go back through and review some of the terms or keywords that would go with each inequality sign, and then we're going to talk about how to solve some story problems that involve inequalities. So to start off with, we know that this first sign is greater than. My stylus is not wanting to write. Just try my old stylus here. And some other terms that could go with this sign, you might see more than. You might see larger than. Above. Or exceeds. So if our first symbol is greater than, then our second symbol is greater than or equal to. So some other ways that symbol might be expressed, you might see at least. Is not less than. Not smaller than. You might see no fewer than. A very common one that you would see is a minimum. And then I'm going to add one more down here at the very bottom, not under. So our next inequality sign is less than. And you might see it expressed as smaller than. Below would be another term for less than. Or you might see fewer than. I feel like I'm leaving one out for that one. If I think of it, we'll go back and add it later. So then our last symbol is going to be less than or equal to. And you might see this expressed as the maximum. You might see it as at most. It could also be no more than. not, oh, let's try that again, not above does not exceed and in the at the very bottom I'm going to add not greater than. So I'm going to move on, but if you don't have this table complete, just go ahead and pause the video and you can start it back up when you've got this done. So now let's talk about translating verbal sentences into algebraic inequalities. So we're just going to read through these sentences and we're going to find our key words and we're going to make little notes above each term so that we can write this as an inequality. So when you think of sum, you've got to think of what operation goes with the word sum. And that operation is going to be addition. The sum of 8 and a number. So that means you are going to add a variable. I'm just going to use x for this example. Is less than, I'm going to use my less than symbol, and then the number 15. So we have the sum of 8 and a number is less than 15. So now we're just going to write this down as an inequality. So we're going to say 8 plus x, that represents a number because we don't know what that number is less than 15. So now let's look at number 2. We have the product of 11 and a number is at least 33. So I'm going to give you a second to think about what operation goes with the word product. And that is going to go with multiplication. The product of 11 and a number. So this time I'm going to use the letter N to represent a number. Is at least. That means it could be 33 or it could be more than 33. So we're going to use the greater than or equal to symbol. So when we translate this to an inequality, I'm going to give you just a second to try to write it. See if you can write it yourself. So if you wanted to represent 11 times a number, then remember you would just write 11n. When we write inequalities or equations, we typically do not use the multiplication symbol. So we have 11n is at least, that means it's greater than or equal to 33. So if we look at number 3, the quotient of a number and -3 is at most 6. So we have the quotient of a number and -3 is at most 6. So quotient, I'm going to give you a second to think about what operation is associated with the word quotient. And that's going to be division of a number. So let's see, this time I'm going to use y as my variable. And -3 is at most 6. That means it can be 6 or it can be less than 6. It cannot be any more than 6. So we are going to use the less than or equal to sign. So when I take this information, I can go ahead and write my number 6 here. I'll write my number 33 up here. If I take this information and change it into an inequality, we are going to have y divided by -3. And remember, when we write equations and inequalities, we represent division with a fraction bar. So we are going to have y divided by -3 is at most, same thing as less than or equal to 6. So since I don't have a lot of space between number 3 and number 4, I'm going to go ahead and use a different color ink so that you can tell the difference of the problem I'm working on. So number 4 says the difference of a number and 12 is less than or equal to 13. So we have the difference of a number and 12 is less than or equal to 13. So what operation is going to be associated with difference? Okay, difference is going to be subtraction of a number. This time I would like to use K for a number. And then we've got the number 12 is less than or equal to. So we're going to use the same symbol that we used in number 3. And then we've got the number 13. So I'll give you just a second to see if you can translate that and write it as an inequality. Okay, so remember, unless we've got the turnaround words, we're just going to write our inequalities in the same order that the numbers are given or that the values are given. So we have the difference of a number and 12. So we are going to say K minus 12 is less than or equal to 13. And then the last problem we're going to translate is number 5. The sum of a number and 20 is less than or equal to -10. So I'm going to go ahead and change my colors again. So I have the sum of a number and 20 is less than or equal to -10. So if we look back at number 1, we decided that addition represents sum. It's the sum is the answer to an addition problem of a number. Let's see. Let's use I don't know. Let's use F for frame. And 20 is less than or equal to -10. So I'll give you a second to see if you can write that inequality based on that information. Okay, so I am adding a number and 20. So I would show that by writing F plus 20 is less than or equal to -10. Okay, so let's go ahead and go to the back of your paper. And we're going to go over some word problems or story problems. And don't forget, we've got to define the variable. We're going to set up an inequality and solve. And then we always want to include our units. And on these, we are going to go ahead and write our answer as a complete sentence so that you can get used to the different phrases and how to answer inequality problems. So number 6 says, a weightlifter's maximum amount he can lift is 300 pounds. how many 50-pound weights can he possibly lift? So we want to know how many possible 50-pound weights can he lift. Some of our key numbers are 350. Do we have any math action words? Maybe how many? Okay, so we are going to define a variable. We want to find out how many 50-pound weights he can possibly lift. So I am going to let W equal the number of weights. So we know the maximum amount. I'm going to highlight maximum is 300 pounds. So remember when we were talking about equations, I always said, see if you can find a total that can go on the other side of the equal sign. Well, this time we're going to find a total that can go on the other side of the inequality sign. So we know maximum means less than or equal to, and the maximum that he can lift is 300 pounds. We want to know how many 50-pound weights he can lift, and W represents the number of weights. So we are going to say 50W is less than or equal to 300. Now I'm going to ask that you pause the video for a moment and go ahead and solve this inequality. And then start it back up when you have got it solved so you can check your answer. So to solve this inequality, I have W on the left side of my inequality. So I know I am going to work on the left side. 50 is being multiplied times W, and we are going to take the opposite operation to undo that multiplication so that we can isolate W or get W by itself. So I know I'm going to divide by 50. And what I do to one side, I've got to do to the other, so I'm going to divide 300 by 50. 50 divided by 50 is just 1. That cancels out, so I'm left with W. Now I'm going to carry down my inequality sign, is less than or equal to. And then when I divide 300 by 50, I get 6. And then you always want to label your answer, so 6 weights. And I would like to go ahead and write our answer as a complete sentence. So we would say the weightlifter can lift and we can say less than or equal to, but when we typically speak, we don't use those terms. We would say something like no more than. Six weights. Or if you wanted to be more specific, you can say 6 50-pound weights. Okay, so for number 7, you purchase a t-shirt for $8.95, and then you spot a pair of jeans that you would like. You have a budget of $25. Find the amount of money you could spend on the pants. So our key numbers are going to be $8.95 and $25. The question is, find the amount of money you could spend on the pants. Math action verbs, maybe find the amount. Sometimes that gets tricky. Okay, so I'm going to highlight, I'm going to highlight the word budget. So budget means that is the amount of money that you have to spend. You cannot spend more than $25. So we know our inequality is going to be less than or equal to. Let's start off by defining a variable. So I'm going to say M equals the money that could be spent on pants. So I will just say money spent on pants. So if I have a budget of $25, that means that's the most I can spend. So I cannot spend any more than $25. So I know I'm going to have something is less than or equal to 25. Now, I spent $8.95, and now I'm going to spend something else on the pants. And M is representing the money spent on pants. So I'm going to say M plus 8.95 is less than or equal to 25, because when I add the money I spend on the pants and the $8.95 I spent on the t-shirt, that cannot be more than $25 because that's the max amount of money I have to spend. Now I'm going to ask you to go ahead and pause the video and go ahead and attempt to solve this yourself, and go ahead and press play when you are ready to move on and check your answer. So to solve this inequality, I am going to subtract $8.95 because my goal is to isolate this M. I want to get M by itself, so I need to get rid of $8.95. So I'm going to take the opposite of addition. I'm going to subtract $8.95. What I do to one side, I must do to the other. And when I subtract $8.95, I get M is less than or equal to, and remember I'm going to include my unit, so since I'm talking about money, I'm going to put the dollar sign. And 25 minus $8.95 is $16.05. So if I wrote my answer as a complete sentence, I would say I can spend a maximum, or you could say no more than, of $16.05 on pants. Okay, if we look at number 8, Mrs. Scott decided that she would spend no more than, let's go ahead and highlight no more than, $120 to buy a jacket and a skirt. If the price of the jacket was $20 more than 3 times the price of the skirt, find the highest possible price of the skirt. Okay, so our key numbers are going to be 120, $20, and 3. Our question is, find the highest price of the skirt. And our key math action words. We've got times. Maybe find the highest possible price. No more than. More than. I think that's all that I can come up with. So I want to know the highest possible price of the skirt. So I'm going to use S to represent the price of the skirt. And remember, you can use any variable that you would like to use. Okay. So I know that Mrs. Scott is going to spend no more than $120. So that means we're going to have less than or equal to 120. So she bought a jacket that was $20 more. So more than is going to be addition. But remember, when you see than, it's also a turnaround word. 3 times the price of the skirt. So if the price of the skirt is S, and we want to represent 3 times S, we would say 3S, and more than means plus 20. So our inequality would be 3S plus 20 is less than or equal to 120. So please pause the video, solve the inequality, and then come back to check your answer. So the first thing we want to do to solve this inequality, we're going to find our variable. Our variable is S, and it is on the left side of the inequality. So we want to move the 3, and we want to move the 20, so that S will be isolated. It will be all alone on the left side of the inequality. We always want to undo addition and subtraction first. So since 3 is being multiplied times S, we're going to wait to undo that multiplication, and we're going to undo that plus 20 first. So the opposite of addition is subtraction. So I'm going to subtract 20 from both sides. And 20 minus 20 is 0. So I am left with 3S is less than or equal to 100. I'm going to go ahead and carry my inequality over, so I've got more room to work. So again, I have 3S is less than or equal to 100. Now, since 3 is being multiplied times S, I'm going to undo that multiplication by dividing by 3. And I need to divide both sides by 3. So my 3's are going to cancel out, and I'm left with S is less than or equal to 100. Sorry, 100 divided by 3. We are going to round it to $33.33. And we could say the highest possible price of the skirt is $33.33. Okay, last problem we're going to do. Oh, let's see. We'll go with bright blue. So number 9, you are babysitting and you make $10 an hour. If you want to make at least, I'm going to go ahead and highlight at least $45. How many hours must you work? So, I'm going to ask that you kind of take a minute and work through this on your own. Pause the video and then come back to it. But I challenge you to see if you can figure this out on your own. Okay, so I'm going to start by circling my key numbers. So I've got $10 and $45. I'm going to underline my question, how many hours must you work? And I'm going to box any key or any math action words. So I'm going to say how many. I'm going to say at least. And I think that's all. So to set up this inequality, at least $45. So 45 is going to go on the other side of my inequality sign. And if I want to make at least 45, that means I want to make $45 or more. So I am going to use the greater than or equal to symbol. So it'll be greater than or equal to 45. Oh my goodness, I forgot to define my variable. Let me go ahead and write my greater than or equal to 45 by the inequality. And we want to know how many hours you must work. So I'm going to let H equal hours worked. Okay, so if you can make $10 an hour and H represents the hours you are working, then we would show that by putting 10H, or 10 times H, is greater than or equal to 45. Now we've got a simple one-step inequality. 10 is being multiplied times H. We're going to take the opposite operation so that we can isolate H, and we are going to divide both sides by 10. My 10s cancel out, and I'm left with H is greater than or equal to 4.5. And I always want to label my answer, so 4.5 hours. So if we wanted to write our answer as a complete sentence, we can say, I must work at least 4.5 or 4.5 hours to earn $45. And you could say to earn at least $45, or you could say to earn $45 or more. But $45 is the minimum that you want to earn. So please feel free to let me know if you have any questions after you have gone through these notes. I hope you guys have a great weekend.